want to. This is you're now part of the Beagle community. We have an IRC channel that typically has between 150 and 200 people on it every day. We have a 100,000 member forum. It's really the structure of a mailing list because a lot of the experts that we collaborate with really prefer to have it in their email inbox and collaborate the way they collaborate, right? So not forcing them to go off into some other person's forums where it lives in somebody else's database, right? It's sitting in their email inbox. So we try to follow those types of rules of collaboration. And part of that is sharing the hardware, right? The design. Everything is open source. These are designed in CADSoft Eagle. The Pocket Beagles are available in Eagle and in KiCad, which is an open source layout tool. You can get all the detailed documentation on the chips. You can buy the chips in quantity 1 through distribution. So if you wanted to make a variant of this, you can. And you're encouraged to. To boot them, you don't need a binary blob, right? So you're not relying on that. We work from open source tools right from boot, and we'll talk a little bit more about that. So we're focused on having you understand what's there and even making your own. And we do take input from our community. The Beaglebone Blue is an excellent example of that. Again, the robotics cape came from the University of California, San Diego. We took the Beaglebone Black Wireless, we put them together on a board. There you go. Right, that's what that is. They run hundreds of students through their mechatronics course with the cape, and then said, okay, well, we kind of figured out what we want to have on there to do some mechatronics. How do we make that affordable and accessible to as many people as possible? And putting it all into one board helps foster that. We definitely want to support people going into business, right? That means, for a lot of people, that means when you do enough volume, you don't buy a Beagle. You take and spin the design and do your own. There's no royalty involved. As long as you don't put the Beagleboard logo on there, go for it. Because I work for Texas Instruments, that makes it nice. You still have to buy a TI processor if you want to really be a clone, so that all works out. But the foundation isn't really is strongly built not to be dependent on TI. If TI got bored of us tomorrow, I'd wonder if I would still want to work at TI. But Beagleboard would go on, right? The Beagleboard Foundation itself, its only real asset is the trademark on the logos. So if you use the Beagleboard name, then you need to pay a royalty to the Beagleboard Foundation. So that's the only real intellectual property. All the designs are released as open source, and people can spin variants and go to market. And then of course, really that brand is really about the collaboration of the community that's behind it. I don't need to explain to you guys what embedded is or what type of typical embedded stuff is. I will say that where things really start to shine is when you have people behind it taking Linux and putting custom distros around it, right? With the Beaglebone Blue, we were able to do something nice with this thing called librobot control, because we kind of knew what the peripherals were about around it. And so we'll be playing in here primarily with librobot control and the example applications that come out of that library. So that helps a lot, but there are other interesting ones. Like RGPilot runs on the Beaglebone Blue, for example. And that one's a full kind of rover control or quadcopter, so it's got all the PIDs you need, all the real-time interfaces you need to.
What's the name of it?
RGPilot. That's a great one to. Put it in the notes. We're still pre item 1. But people put these bits of software together that really help people's end experience. That's why what I want to show you coming right up is how to take the board and actually make your own image. So we're going to flash the board, and then we're going to, from the board, make a flasher image so that you can actually share that image with other people. So if you start making your own images, then you say like, well, I've got all this stuff integrated. You could just essentially have this same experience replicated in other people that have the same hardware. It allows people to do really cool things like machine kit. All right, so there's PRU firmware loads. So those little microcontrollers are driving the stepper motors. You have hard real-time stepper motor for doing things like 5-axis CNC mills. They have GUIs integrated so that you can, to jog the CNC, load and run G code. There's HAL layers in so that you can say, okay, well, I've got the stepper motors hooked up to these pins.
What the
Those
hell?
things all become software configurable. Hardware abstraction layer. So the hardware abstraction layer allows you to do things like define the geometry without like necessarily writing a ton of code. So there's a little bit of Python kind of gluey stuff. But if you want to, say the turn of this motor is going to generate, some geometry change, the HAL allows you to abstract that away so that your G code can talk about position rather than where you're moving the head, rather than the geometry of the arm moving the head. So that the HAL deals with the geometry, and then the G code just deals with head positioning. And then all of that goes right down to, here are the pins where I send the pulses out to the stepper motors in order to make that motion. So people were able to pull cool things like that together, things to do Christmas lights. I'm not going to spend any more time on those examples, but there's a good amount of them. But I just wanted to get to the point of encouraging you for best practices to start kind of making your own image. There is the kind of the first pass is make your modifications on the target and copy it back to an SD card, then extract that SD card off into a file and then distribute the file. That's kind of the first pass. As you want to get a little bit quicker in your turns, there's this tool called Image Builder, where you can customize the packages that get integrated and produce an image entirely offline, right? So you don't have to do anything on the board itself. So we build our images with this thing called Image Builder. While I'm thinking about it, I'm going to write down the URL, github.com, Beagleboard Image Builder. That requires a beefy ARM system. We use a Beagleboard X15 in order to run Image Builder. You may not be ready for that, but ultimately that's kind of where you want to step into when you start bundling extra packages together and do these things like the nightly builds, like what we've got here for the workshop. I don't need to spend any time here for this, but essentially the community is kind of like the peer U was one of these things that initially TI didn't want to support publicly. It was just going to release some set firmware loads that people could run on there to kind of create soft peripherals, do some things that would run on those. But I managed to get some documentation out on the outside of TI, and the community support just started to show up, right? Very much working with the open source community. It's not always about making things super easy. It's about making them possible and giving them motivation for why they want to go do that. And we saw things come out with GCC compiler support, debugger support, right, that were homegrown by the Beaglebone developer community. You just run it. I went to get coffee at Maker Faire, and the coffee stand, it's like, oh, you saw my Beagle hat. We're using a Beagle inside to control our coffee maker, right? So these guys are using the PRUs in there to drive the stepper motors that were doing the pour over for the coffee grind. So they built their coffee machine And now they have a business. If you go to Port Steady, you can buy a coffee machine with the Beaglebone in it. Right. They don't talk about the Beaglebone. It's just part of their solution. So that's it. I don't want to spend too
I
much.
saw something that said PRU Speak Interpreter.
Yeah, that was my vision of how to get started with the peer review in days past. I'm still very much interested in it, and you can still play with it. It's an interpreter that runs partially in Python on the host and partially sends down some commands to the peer reviews, so that BotSpeak is the name of a language that was created by Chris Rogers at Tufts University, the Center for Engineering Education Outreach, and he's looking at ways that he can get kids, young kids, elementary school kids, programming robots early on, and so he does a lot of stuff with Lego Mindstorms. He's doing stuff with other platforms now, and one of the things that he created is actually for somebody first kind of understanding programming and assembly language is actually if a understanding assembly where it's instruction is not that hard to do, and it's very deterministic, right? It's just do this operation, do this next operation, do this operation, and potentially make a decision and branch back. So we created a high-level assembly language where the assembly language included basic primitives like set PWM output, right? So just that's an opcode is PWM output to this, right? Or digital I/O input, right, into variables. So we created this high-level assembly language that even kids could sit there and write, or you could design, you could have other tools output that as a language. So we did an implementation of that for the PRU called PRU Speak. The time
So
I
it
wrote
has
this,
nothing to do with speaking or voice?
nothing to do with speaking.
Okay.
It's a way to speak to robots.
We want to be able to speak to our robot vocally. So that's, if there's any
one of the
opportunity
homework
to touch
assignments
on
was to
that.
get it to output over I²S, so I did that one.
Super.
So output is easy when you're talking about talking to it. Now I guess you have a microphone in your camera.
Yes.
Most of these USB cameras should have microphones in them.
Yeah.
So, is that we're gonna tackle that one as part of our?
Maybe
tomorrow?
not. Maybe not. But if there's an opportunity, we want to know. Or if there's a simple tool, we want to know about it.
Okay. Yeah, because I think I'm gonna just reset my brain a little bit as I kind of push through here. Is that we want to get to the point today, reproducing images work, right? So how do we scale? How do we get whatever we customize in here to kind of scale out? And then the project is what again?
I have to go back to the agenda. So we have questions about good Wi-Fi connection, SD card, onboard. Okay, so we want to know if the onboard examples that we've seen in the libraries and totally ignored, sorry, not in libraries, in the file directory that comes with the Beaglebone image. We want to know if any of those are things that we should be using.
But we want to do some visualization. We want to be able to create a visualization tool. So I think we'll focus on creating an image this evening that creates a visualization tool for different inputs on the board, right? Things like the accelerometer, the magnetometer, because we wanted to monitor the magnetometer, wheel positions. So we're going to make an image and reproduce it across different boards. Where if you put that image in, it's going to have a web server, and it's going to give you visualizations of the information of what's running on the board. So let's try to make sure we kind of set up for that. So both the readings of the sensors as well as the reproducing the image, and then the other side of the output side of the visualizations.
Okay.
So that'll be kind of our high level goal with some of these smaller milestones in between. Yeah, so let me just.
Oh, I'm putting it at the bottom of Wednesday.
Okay. Sorry, I'm messing up the notes a little bit for now, but we can come back and clean them up. I just want to try to make sure some things are down. So the best process for updating the board image and getting so getting the connection. So has everybody downloaded the SD card?
Has anyone not downloaded the SD card image? Oh, do you mean flashed it?
No, I think we're gonna start